ML channel. Today we are going to see the last topic of end-to-end machine learning project, and the topics we are going to cover is fine-tune your model, and second is launch, monitor and maintain your system. So what are the subtopics we are going to see? Here it is: GridSearchCV, RandomSearchCV, Ensemble method, feature importance, and then last one is the evaluate the model on test data and launch, monitor and maintain your system. So these are the topics we are going to cover today. So see, it is very important. When I say fine tune your model, it means that as of now we have decided that what models we are going to see. In my previous video I have explained that we have explained the linear regression model, decision tree based model and the random forest based model, and what are the criteria to select which model is best for your data. So after all, we understood that the random forest is the best model for my data. Now once you select the model, it is very important to find out what are the best parameter we can use so that my model perform, that is random forest perform very well on any kind of generalized, on any kind of data or any kind of test data. So for that we are going to use two methods. First method is GridSearchCV and second is a RandomSearchCV. So we are going to see in detail how these are helpful. Now even we have the data, sometime this kind of fine tuning is not achieved by these two methods. So in that case we have to go for the Ensemble type of modeling. So namely I can say there is a let's say XGBoost, and the random forest. These are the popular Ensemble method, but there are very sub methods are available. You can use any Ensemble method. Ensemble is nothing but the combining the different models all together and get the prediction. Then feature importance. So these are the random search and GridSearchCV also help you to give the what are the features are important to your model. So those features are important, you can consider, and other you can discard. And after that, once you have the all the model and parameter is ready with you, you can evaluate that model on test data, and at the end we are going to see how to launch, monitor and maintain your system. So to see how practically we can achieve, let me reconnect my Google Colab, and let me so it will take some time to reconnect my this Google Colab notebook, and let me run once again so that okay, it will take some time. Yeah, so it's connected. Now let me run all the code. Yeah, so this will take bit amount of time. Now notebook is ready. So let's so we already imported the GridSearchCV from the sklearn model selection package, and now we are going to select some the parameter. So the way we are passing the parameter, for that we have to mention the dictionary, and for that we are using the parameter, say param grid. Okay, and in this param grid we are passing a list, and this list contain a dictionary. In this dictionary we know that the random regressor, okay, the random forest regressor contain few parameter. That is, first is the n estimator. So in this video I'm not going to explain what each parameter and what is the meaning of that, but in upcoming video when we are discussing the algorithm in detail, so I'll definitely explain the meaning of this parameter. But just to limit the scope of this video lecture, just keep we require few parameter, and first one is the n estimator. So other person can try want to try the different value of n estimator. Let's say in this example we want to try with the 3, another is 10 and another is a 30. Similarly, there is one more parameter we are passing called as a max feature. Max features. In this max feature, a person want to try, or we want to try with the, say, let's say value 2, 4, 6 and 8. So we are giving these numbers are randomly, but definitely there are few strategies we have to follow while selecting this parameter. But as a just to explain how the GridSearchCV works, I'm giving the random numbers. Now this is a one set of parameter we really wanted to try. Now there are again we want to try with the another set of parameter. Let's say uh, same, but there are additional, there is one more parameter called as a bootstrap, and as a default we wanted to pass this bootstrap as a false. So what is the difference between the first and the second? We are just adding one more. So there are the there are the number of parameter you can use while training your machine learning algorithm, or the specifically in our case a random forest regressor. But we are it is not require always to try with the many, but mandatory one is very important. However, you can use the other parameter whatever you require. Okay, so in first set we are using n estimator and max feature. Now in second set we are adding the one more feature called as a bootstrap, and we are also using the n estimator. So let me copy this and just to save our time, paste here, and in this now I'm going to pass the two parameter 3 comma 10, and here we are going to pass 2 3 comma 4. So don't worry, I'll explain you the logic how it works, but let me first do the uh, code writing here. So this way we want our algorithm to run, to train our algorithm on this parameter. Okay, and then after that we have to let me initialize the our model, that is the random forest regressor. Yeah, it's come, and after that we are going to call our grid search CV. So for that I'm giving grid search, and let me initialize the grid search CV. Yeah, yeah, it is good. And here I'm going to pass now the various different thing. Now the important pass, first important in this grid search CV is we have to first give the forest regression, that is the algorithm which we where on which we want to try this param grid. Second, the param grid definitely, and this also include the cross validation. Now if you don't know what is a cross validation, please watch my previous video where I have explained in detail what is cross validation. So the good part of this fine tuning model, it itself include the cross validation, so it avoid to pass this as externally. So this is a cross validation, and for the scoring we are using the negative mean square error. Right, and then after that we say return train score as a true. So by declaring this we make sure that we will get the train score. So this way we can initialize the grid search CV. So if anyone wants to use grid search CV, please remember these are the important stuff. You have to give the first as a algorithm which we want to try, then the param grid, then cross validation. You have to mention the scoring. You can use different scoring metrics as per your requirement and other things, but these are the mandatory. Okay, now let's run the cell. Okay, so so as of now we have just did the declaration. Sorry for that. Let me pass the input data, that is our train and train data, that is grid search, and let me say fit, and here I'm going to pass my x data as housing prepare, and my target label is housing labels. Is it coming? Yes, I see it, housing labels. So this way, and I did spelling mistake here, now it's correct, housing prepare. Now let's run and see how this grid search. Okay, negative means square, I again it's not means it's so when you start typing you will get such a minute error, but you will learn invalid parameter n estimator. Okay, so again estimator. Okay, it's yes, sorry for that guys. Okay, now it's running, so definitely it will take some time to you know try out all this. So still it's going on, let me explain you how actually it works. Okay, how the param grid do the calculations. So let me open my pen for that, uh, so that it will be very easy to explain you on board. Yeah, I got my pen. Now let me take pencil. Okay, and I'll select, let's say, blue color. Okay, and now here it is. So how it works, so see, look at the screen, guys. So how many parameter we are passing at first phase? Oh, there is a error. Let me see what's error we are getting. Oh, sorry, 1 second, let me delete. Yeah, so we have invalid parameter. Okay, again the spelling mistake. Okay, next time I'll try to make sure that this will not happen. Okay, it's a bootstrap. Now let's say, yeah, it's running. Okay, I hope so this time it will run perfectly fine. So let me take the pencil again and explain you the logic behind this GridSearchCV. So if you look at this board, first time we are passing the, oh, the pencil is very big. No, it's perfectly fine. So if you see, look at this board, we are passing n estimator 3 combination, right? We are passing combination as a 3, and here we are passing max feature as a 4. So it will take 3 into 4. So 3 into 4. So first time it will take each parameter, it will take first 3, it will take max feature as 2, it will run. So similarly, how many parameter we are passing? 3 parameter passing, and max feature 4. So how many combinations? So we have 12 combinations are running here. In in the second type, we are passing n estimator 2 and the max feature as a 3. So how many combination it will try? 2 into 3 as a 6. So first it will try 12 combination. Let me write. And second time it will try the 6 combinations. So total how many combination it will try? 12 plus 6, that is the 18 combination it will try. So remember guys, it will not try because bootstrap we are only passing the one parameter, that is false. But if you mention the true, then definitely that will be also considered as a part of combination. But as of now we are only passing false as a single boolean value to the bootstrap, so it is not affecting much. So first we are passing 12, 6, to total 8 combination it will try. Additionally, we have mentioned CV is a 5. So what happened? So please remember that it will do the cross validation 5, means it will do the 5 times training. So 18 into 5, which comes around to 90. So what this 90 means? So 90 means it will train your algorithm 90 times. So it will try this 18 combination on 5 cross validation set. So 5 times it will run. So 90 times your algorithm actually running internally, and whatever the best one, it will give this one as a the result. So this is a the benefit of GridSearchCV. Rather than you are passing the stuff manually and running all the stuff, all the parameter in a for loop, it will make your work is very easy. So 90 times your algorithm is running. So this is very important to understand the logic behind the GridSearchCV. If you still have any doubt, please go back, watch it, and uh, try to understand. Still have any doubt, please comment it, I'll try to answer there. Now let now this is what the GridSearchCV is happen. But now I wanted to understand what is the best parameter where my algorithm is working perfectly fine. So for that we are using the, we will calling the method call variable call as a best params. So when you enter this, it will give the result 6 and 30. So I can say that my max feature 6 and n estimator 30. So when I select this parameter, my model performs very well. So this way we can understand that these are the best parameter for my algorithm and I can use this. Similarly, you can also get the best estimator as well. So here you can see the best estimator as well, and it will give the same. So there, here you will get the detailed information that random forest regressor, for that these features, that is max feature is equal to 6 and s estimator is equal to 30, is giving the good results. Similarly, you can get the different scores for different parameters. For example, let me show you this code. So what happened, we are capturing our results in cross validation results, and here we are passing the parameters and their mean test scores. So when you run this block of code, you will get the cross validation score for each features. Now if you see the max feature 2 and 3, max feature 2 and 10, max feature 2 and 30, second parameter we have passed 4 and 3. So it will try each and every combination, and this will give the corresponding cross validation scores. So when you, if you look at whole this result, you can find that the max feature 6 and the 30 is giving the less cross validation score as compared to other one. Please look at the line which I have highlighted here. This will clearly show that the cross validation for this features, for this parameter is good, and which you will get easily with this variable called as a best params. Okay, this method best params. So I think this is, I'm just showcasing you just to give the glimpse how the GridSearchCV is very easy to use rather than using manually. So this way I think I cover the GridSearchCV. There is a second method called as a RandomSearchCV, randomized search. Now I'm not going to write the code. I can say take this as a homework and try out with you uh, with your own. Okay, and probably you can just comment it once you did it, how you achieve with the randomized search. But I literally wanted to share with you how actually the randomized search works practically. Okay, so and what is the difference between the randomized search and the grid? So if you see in the grid search CV, grid search CV, we are trying all parameter combination. Correct, we have tried all parameter combination, but in the randomized search we are not trying all parameter. However, we are randomly picking the parameter and try it out for that. So what it means, that it means that, and when it is applicable, see, randomized search is very good when you have the large set of data and your ML model is complex one. So it is very difficult if you try the all ML model on your complex data, otherwise it will utilization of your compute is very high, and your model, your training will take a lot of time if you go with the grids, because the GridSearchCV take all the parameter. But the best part of randomize, it will take randomly. So for example, let's say you are running the randomized search for the 1000 iteration. So the only the 1000 random parameter combination it will take, and it will give the best parameter out of that. So practically both are working the same, but only the difference that in randomized search it picks the random parameter and train your ML algorithm on those random parameter. However, in GridSearchCV it will take all the parameter of combination and train your ML algorithm on those selected parameter. I hope you understand this another method, randomized search, but I'll really request you, please code on your own and share with on the comment how this will applicable here. Second is the Ensemble method. So this is the another way of what I can say, fine tuning your model. Okay, one is the Ensemble. Now we know that in Ensemble method, it means, what is Ensemble basically? Let me take pencil once again. Yeah, so Ensemble is nothing but the Ensemble is nothing but the combining the different model. So what happens that when your model single model is not performing well, even using GridSearchCV or the RandomSearchCV, it is always recommended to combine the models. So train your data. So suppose this is your data, you can bootstrap those data and train this data on different model, and whatever the results we will get, we either average it or we can take the max one, the maximum model which perform well. So averaging or the maximizing will work here, and those things is called as a ensemble modeling. So ensemble is nothing but the combining the different model and take the average of those result is called as the ensemble method. So there are the two type of ensemble. We know that in machine learning, one is the uh, random forest, which is also called as a bagging technique, which we have just show you, which I have just show you, and second is the XGBoost, which is a boosting technique. Now I'm not going in detail because this is a out of scope of this this video, but just remember, one is the random, please sorry for the bad handwriting, but please listen my voice and try to understand. One is the bagging and another is the boosting technique. Now this is the third way, I can say, the of fine tuning of your model. Now let's jump to the next topic, that is called as analyze the model, or I can say yeah, analyze the model, or I can say what features are the important that you can also get from the GridSearchCV. So I can, let me give the name to this cell, that is feature importance. Okay, now what it means by feature importance. So what happened during the training, sometime we understood that out of 10 features, some of the features are really not helping for predicting the results. But how do you come to know? So for that, in GridSearchCV there are a method called as a feature importance. Okay, let me show. So when you run this, after running this, we will get what are the features are important. Okay, so now it is giving some array, but if you really wanted to see which features are important for our ML algorithm, for that there are set line of code we need to execute. So I'm just, to save our time, I'm just pasting the code here. So these are the extra attribute. If you remember, we have derived earlier: rooms per household, population per household, bedrooms per household. Okay, and then we are giving the categorical. So these are all are the categorical. Sorry, so there are some categorical encoder features we are passing to the categorical encoder. Then we are trying to do the one hot encoding, and then we are passing all these attributes. So we have number of attributes, extra attributes, and the categorical one attributes into the attribute section. And then once you run this set line of code, you will come to know which are features are important. Now if you see the score which are close to close to 1, we can say that those features are very important. And the feature which are not close to 1, you can say it's very away from the 1, is really not playing, not adding any value if you use them in your training the algorithm. So this is again the best part of your GridSearchCV, which will help you what features are important or not using this. Okay, so it's very easy what I'm doing. The logic is very simple, guys. We are just combining the attributes, because we know that there are few attributes are the numerical, which you can use as directly. Then there are extra attributes which we have used in our um, algorithm, or you can say derived attributes. And there is a categorical one hot attribute which we have converted using the category. For that we already have the full pipeline ready, so we have picked those directly and passed to here. So when you zip this using the feature importance and attributes, you will get this result, and these are all in the sorted order. Okay, 0 0.3, 0 0.1, 0 0.1. Okay, these are all are in sorted order. So this way we also understand which features are important and which features are not. Now this way we understood that how to use the fine tuning and how to find the most important feature. Now the last part of this uh, last part of is that to test evaluate your model. Now we have understood that we have the random forest as a main algorithm to train, and we also understood that the parameter we have to pass is a 3 and 30. The n estimator is a, I think, something 6, and the max feature is a 30. Now it's time to evaluate your system on test data. Okay, so this is the time. Again, how to evaluate? Simply, we already have the test data ready. So as I say, the making a pipeline ready is very helpful, because our test data is a raw data, and to do the prediction we also have to do the transformation. So for that we use full pipeline which we have already created, passing the x test there, we dropping the median house value from our test data and store into the y test, and then at the end the model which we have, that is called as a final model, we already ready, we are passing our x test prepare to our final model and do the prediction. And for this we are using the matrix called as a RMSE, and we have got the results 48,222, which is, I think, simple and well and good. So this way, I think, guys, I have explained all the way how you can select the model, how you can train the model, how you can fine tune the model, how you can get the important feature from your data and did. Now the last and the important part, I'm not giving more time to this, but it is very important to understand that launch and monitor the system. Now slowly in upcoming lecture I'll definitely explain what is in detail, but this is more towards the deployment strategy. So launch and monitor the maintenance system means that once you have decided which algorithm is good, uh, there are general strategies follow is called as a REST API strategy. So what happened in the REST API strategy? The good part of REST API, you can integrate your model with the some kind of REST API program. I can say Flask, Fast API. Then there are other one as well, but you can use this kind of algorithm to generate the REST API. Then you do the containerization so that it is very easy to manage, and once you have this REST API ready, you can integrate this REST API with your application. Okay, with your application, and whatever module of your application is using, you can use this REST API. Now what is the advantage of REST API? It is very easy to maintain your system. It is not dependent on your application. You can suppose, let's say you have 2-3 model with you, let's say model 1, model 2 and model 3. Okay, model 1 is currently in production, model 2 is currently in staging, and model 3 is archive. Suppose somehow your model 1 is not performing well on the new set of data. Okay, for that you can use the model 3. Okay, you can just deploy this model 3 which is already ready. You can just create, you already have REST API, you can map your REST API to this, and it is very easy. So that maintenance of the system, it is very easy in such kind of environment. Now monitor, for the monitoring we have the different cloud based tool called as Azure monitoring, or the Google cloud monitoring, or the AWS cloud monitoring, or you can use the internal monitoring tool which supports the system, so that it is very helpful to understand how your system performing, what is the utilizations, so these are kind of the stuff is very important. But this monitoring is on the system side, but altogether there are also called as a concept called as a data monitoring. So this data monitoring is very important. Somehow whatever data comes, it is very important it fall exactly, I can say, more closely similar to the input data we are passing to our ML model, because we have trained our ML model on the trained data, and it is very important the kind of distribution our trained data follows or our test data follows, same kind of distribution we must get from the new data, otherwise our model will not perform well. So kind of data monitoring is a very important role while when you deploy your ML model, otherwise your ML model may or may not perform well on the new data. I'll this more come into the machine learning system design. I'll definitely talk on this system design in coming days when we are discussing this in detail. But as of now, you just keep this thing in mind. Okay, and this way we have completed our end-to-end machine learning project. I hope this is helpful, and in upcoming video lecture we are going to focus on the classification type of model. Here we have understood regression, but in upcoming video lecture series we are going to see the classification. I hope guys you like my explanation. Please try to like, share, and subscribe, spread this knowledge across the world, so that this will give me a motivation to do this thing, as much as possible. Till that time, thank you.